the questions on amines and diazotization reaction. So write the equation and condition to produce amine using CH3Cl. So if you have CH3Cl, okay, you react, okay, if you want to produce amine, okay, so you react with ammonia, okay, you react with ammonia, okay, whereby it is going to give you CH3NH2 plus HCl. Okay, so whenever halogenoalkane reaction, so this is going to be a nucleophilic substitution reaction. So what are the condition? Okay, so please remember the condition is going to be the ammonia that you use, okay, must be in excess. Okay, ammonia must be in excess. Okay, and you must actually use ethanolic condition. Okay, and then heat, okay, under reflux. Okay, these are the conditions that you need to do. You need to maintain, okay, so that you have the amine, yeah, in that way. Okay, so that is one of the ways. So there are more ways, yeah, but later on, okay, we will actually go through one by one. So this is one, yeah. So number two, write the equation and conditions to produce ethyl amine from methyl chloride. So you see methyl chloride. So methyl chloride, okay, if you look at methyl chloride, methyl is going to be CH3 only, okay, CH3Cl, and you want to form ethyl amine. So now you have CH3, CH2, and H2. The first thing that you notice over here is going to be there is an increase in carbon. Okay, whenever there is increase in carbon, there is only one reaction that you need to actually remember when it's going to be increase in carbon. You react, okay, you react with KCN, ethanolic, okay, ethanolic KCN, heat under pressure, okay. So heat under pressure, ethanolic KCN, yeah. So you are going to actually get, okay, you will get CH3Cl plus KCN. You will get CH3CN nitrile, okay, and then once you have the nitrile, okay, there is going to be further reaction, which is going to be the reduction. So do remember, this is going to be nucleophilic substitution. And there will be reduction reaction, which is going to be, I take the CH3CN, and then I am going to reduce, okay. If you want to reduce, okay, there are two types of reducing agent that you can use, okay, for nitrile, okay, which is going to be, you can use LiAlH4 in dry ether, or you can use hydrogen with nickel catalyst, okay. All these conditions, okay, you can get CH3, okay, the two hydrogen will come over here, another two hydrogen will come over here, so you need 4H, so you will have you will get CH2 and H2. Okay, so this is going to be your ethyl amine, okay, ethyl amine. So these are going to be two reactions that you need to follow, okay, for this reaction, equation number 1 and equation number 2. Okay, that is going to explain question number 2. So question number 3, write the equation and conditions to produce amine from ethyl chloride. So from ethyl chloride, okay, so let's say we just select one ethyl chloride. So CH3, C double bond O, Cl. Okay, this is an ethyl chloride. And I want to actually produce, okay, amine. Okay, so I want to produce amine. So basically you want, okay, before I write, okay, so I'll just write down, it is going to produce amine. So you see, whenever you have ethyl chloride, okay, ethyl chloride, you need to recall what are the reactions that ethyl chloride can undergo. Yeah. So ethyl chloride can undergo reactions with what? Water, okay, alcohol, okay, phenol, amine, okay, ammonia, okay. So all these going to be reactions involving, okay, ethyl chloride, the 5 reactions. So if you have this ethyl chloride, how do I change it into amine? Okay, so when I see how to change it to amine, the only thing that I can think of is maybe first, okay, I react with ammonia. Okay, I react with ammonia or amine. Okay, I will get amide first. Okay, so first I get amide. Okay, I get amide. After that, you can change it to amine by reducing. Okay, reducing amide. So what I can do over here is, okay, so I write CH3COCl. Okay, I can react with ammonium. So do remember, this is going to be addition elimination reaction. Okay, addition elimination reaction. So you are going to get CH3CO, okay, NH2, and then HCl. Okay, so this reaction, okay, it happens at room temperature. Do remember, ethyl chloride is very reactive, room temperature. So you are going to get amide over here. So once you get the amide, okay, you can actually react the amide, CO and H2. You can reduce the amide. Okay, there is only one way to reduce amide, by using LiAlH4 in dry ether. So once you do that, okay, this one I told you how to remember. Okay, you take out the O. Okay, so the hydrogen will come in, another hydrogen will come in, then another hydrogen will come in, another hydrogen will come in, total 4H. Okay, and you will have CH3, CH2, NH2, and then 1 mole of water. Okay, so this is going to be the reaction. Okay, there are total 2 reactions involved in the conversion. So number 1 and number 2. So that is going to be the answer for question number 3. So number 4, write the equation and conditions to produce phenylamine from benzene. Okay, so benzene, okay, going to form phenylamine. So number 4, okay, from benzene, you are going to form this. Be careful, okay, benzene, they don't react with ammonia. Okay, they don't react with ammonia. So don't go and straight away react with ammonia. Okay, so this one, okay, what you need to do first is going to be, if you recall, okay, benzene, okay, can react, okay, with HNO3, concentrated nitric acid and concentrated sulfuric acid. Okay, they can actually give you nitrobenzene. Okay, nitrobenzene, you can reduce them, okay, by using tin and concentrated HCl. Okay, tin and concentrated HCl. Okay, then after that, tin concentrated HCl. After that, I think you need to use sodium hydroxide aqueous. Okay, and then, okay, you are going to actually get this amine, yeah, phenylamine. So the reaction, okay, so I will write down the first reaction is going to be benzene is going to react with this. So I am going to get nitrobenzene and water, 55 degrees Celsius, concentrated HNO3 and concentrated H2SO4. Okay, so once you get this, okay, this nitrobenzene, they are going to be reduced to give you phenylamine. So how to do this also quite simple. Okay, you take out the 2 oxygen from here. Okay, the nitrogen, okay, will react with 2 hydrogen. So 2 hydrogen came in, another 2 hydrogen have to come over here, 2 hydrogen over there. Total 6 hydrogen. Okay, and then you are going to get 2 moles of water. So this is going to be done, okay, with the presence of okay, not the LiAl. This one is thin concentrated HCl. After that, you react with sodium hydroxide aqueous. Okay, this one heat. Okay, or they say hot. Okay, hot thing. Okay, or heat. Okay, so these are going to be question number 4. Okay, question number 4. Okay, done. Write the equation and condition to produce phenol from nitrobenzene. Okay, so number 5. Okay, I want to produce from nitrobenzene. I want to produce phenol. Okay, how to do that? Okay, how to do that? Okay, from nitrobenzene to produce phenol. Okay, so you need to recall, how do you produce phenol? So something to do with the benzene diazonium salt. So what you need to do first, okay, is going to be you change this into phenylamine. Okay, once you change it into phenylamine, so you react, okay, with HNO2, okay, and then HCl, okay, you react, okay, and then they are going to give you this salt, okay, N2 plus Cl minus. From there, you can react with water, okay, you warm, and then you can get phenol. Okay, so this is the thinking process. Okay, the thinking process. So what are the reactions involved? Okay, let's actually write down over here. The first reaction, okay, is going to be the nitrobenzene. Okay, you need to change it into phenylamine. So no need to rewrite again. I'll just copy over here. Okay, this one. So this is the first reaction. Okay, that's the first reaction. Second reaction, okay, once you have this phenylamine, okay, you need to react, okay, with HNO2 and HCl. Okay, how do you prepare this? Please remember, HNO2 is prepared by, okay, I'll write down over here. You need to prepare them separately. HNO2 is prepared by NaNO2 plus HCl, where they are going to give you HNO3, HNO2 plus NaCl. Okay, you will get that. Okay, so this one is done at 5 degrees Celsius. Okay, 5 degrees Celsius to prevent it from to prevent this from changing into nitrogen gas. Don't want to decompose. Yeah. So here, what is going to happen? You are going to get N2 plus Cl minus. So this one and this one joined together with this. Okay, so I have 2 hydrogen there, 1 hydrogen here, 2 oxygen, and 1 hydrogen over there. So you can see that you can form 2 H2O. Okay, so once you get this salt, okay, you need to move on. Okay, so once you have this salt, okay, you need to react N2 plus Cl minus, you react with water, which is going to be warm. Okay, you are going to get phenol, and okay, if phenol OH went over there, so it will give you N2. Okay, so you have H and Cl, so it's going to give you HCl. So you have phenol. So in total, how many reactions that we are dealing in this reaction? So 1, okay, 2, and 3. Okay, 3 reactions. So that is going to explain for question number 5. Question number 6, okay, write the equation and condition to produce yellow dye from benzene as a starting material. Okay, I'll go very fast for this. Okay, so from benzene, okay, you need to change, okay, first of all, okay, you need to change, okay, you react with the HNO3, okay, you will get nitrobenzene first, okay, and then you will get NO2, H2O, okay. So once you get the nitrobenzene, from nitrobenzene, you need to change, okay, you need to react, okay, with 6H, okay, SN, okay, concentrated ACl. It's the same, yeah, that I mentioned earlier. You are going to get NH2 amine, phenol amine, okay, plus, okay, 2H2O. Okay, once you get the phenol amine, so please refer to all the previous equation, yeah. So this one 55 degrees Celsius, concentrated H2SO4, okay, concentrated, let me write it somewhere, okay, concentrated H2SO4, and then plus HNO3, okay, concentrated. Okay, so once you get this, okay, you are going to get the phenol amine. Okay, so phenol amine. So now what we want to get is going to be yellow dye. Okay, so we still do the try to get the this reaction. So let me take this one. Okay, we need this reaction. Okay, you are going to get the salt. Okay, so after you get the salt, okay, you are going to react this one N2 plus Cr minus. You want yellow dye, so you react with nitrogen, okay, combined with CH3, combined with CH3, not with phenol, yeah. So you are going to get, okay, like this, N double bond N, join with NCH3, CH3 plus, okay, one of the H and then Cl over there, so HCl. So this is going to be the yellow dye. Okay, so this reaction, the conditions, okay, please remember, okay, the conditions for this reaction, okay, must be less than 10 degrees Celsius, okay, so 5 degrees Celsius, and then this one, okay, please check, okay, whether you need sodium hydroxide. I think you need sodium hydroxide first, okay, please check, okay, but anyway, these are the reactions to give you the yellow dye, okay, so this one done. Can amine react with halogenal alkane? Explain your answer using equation with any. So here, okay, to explain question number 7, I'll just use the equation number 1, because the reason why it must be done in excess, okay, because this is also going to behave, okay, the amine itself is going to also behave as a nucleophile. So there will be reaction. So CH3Cl, if you react with CH3 and H2, okay, there will be reaction where they are going to give you CH3 and HCH3, and then you will get HCl. Okay, so this is going to give you amine also. Yeah. So reaction of amine, okay, with halogenal alkane do give substituted amine. Okay, substituted amine. Okay, the equation is given. Okay, so what are the conditions? Same, excess. Okay, if you need to use the excess amine, or it must be ethanolic. Okay, and then you still need to use heat under reflux. Okay, this one done. So question number 8. Compare basicity of different classes of amine. Yeah, so this one no need to spend a lot of time. So number 8 is quite simple. Okay, so if you have primary, okay, secondary, and tertiary, okay, so the more R group, it means that more electron donating group. Yeah. So if you have more electron donating group, okay, the lone pair, okay, will be repelled more. Yeah. So if let's say I have a lone pair over here, I have 3R groups, that lone pair will be repelled more to be available to be bonding with a proton. So it means it's going to accept proton better. So it means that, okay, if I go from here to here, okay, I can say that, okay, my basicity, okay, basicity increases. Okay, why? Because more R group means more electron donating group. Yeah, so you can actually explain that. So that is going to be question number 8. Explain about oxidizing and reducing agents used in alcohol, carbonic compounds, nitriles, nitrobenzene, and amide. This one, explain about all this. Okay, this one for alcohol. Okay, I will actually okay, maybe for alcohol, okay, maybe I'll scribble fast. Yeah, so for alcohol, okay, we know primary alcohol can change into aldehyde, aldehyde can change into carboxylic acid. Okay, so they didn't mention about others, so maybe secondary it will go to ketone. So if I want to use oxidizing agent, yeah, strong oxidizing agent, okay, KMnO4, K2Cr2O7, okay, you can oxidize them. Okay, but okay, let's talk about reducing agent. If I want to reduce back, okay, if I want to reduce back, you can use, okay, you can use LiAlH4 and NaBH4. Okay, so this one room temperature, this is going to be dry ether. Okay, so you can do that. Okay, but if you want to change carboxylic acid to primary alcohol, you can only use LiAlH4 only. Yeah, please remember that. Okay, so this is going to be related to alcohol and carbonyl compounds. Okay, now if you look at nitriles, okay, nitriles on the other hand, yeah, nitriles we only learn about reducing reduction. So nitriles you can reduce, okay, but you reduce using LiAlH4 in dry ether only. So you will get amine. Yeah, you will get amine. Nitrobenzene you can reduce, okay, you can use tin, okay, concentrated H2 HCl, and then you heat. Okay, you can actually reduce nitrobenzene to become phenylamine. Yeah, and amide, okay, you can only reduce using LiAlH4. Okay, okay, I think I miss out here. Yeah, nitrile, not only LiAlH4. Okay, you can also use hydrogen, okay, with nickel catalyst. Yeah, but for amide, okay, you can only use LiAlH4 in dry ether only. Yeah, can amide be oxidized? No. Yeah, so these are the, if you put all this together, yeah, that is what I want. Yeah, so basically these are the things that I want you to discuss, okay, today, and hopefully, okay, you get a good idea, okay, about our lesson for this week. Okay, maybe it's a bit confusing, but I have recorded this session. Okay, please go through this, okay, and please complete this worksheet. No need to submit. Okay, this is going to be your own reference. Yeah, so I will